Welcome to Maths with EJD. Again, we go on to talk about scientific computing with Python. And today, in this particular video, I'll be going ahead to talk about introduction to SciPy. SciPy is scientific computing, and we'll see some powerful things we can do with it. Since you're talking about scientific computing, this is more like the core Python library for that. Okay, so let's see how that goes. All right, that should be the 14th video on scientific computing with Python. And we are talking about introduction to SciPy. Well, this is just a code to, show the SciPy logo. So if I run this, it just shows the logo for SciPy. Yeah, there you have it. That's the logo for SciPy, Scientific Python. So let's talk about the okay, well, before you even go too far, right? If you check the description box, you'll find a link to all the notes so far. I think I have up to 15 notes there now, including the one for the next video after this. So the idea is that you can download these notes. In the very first video, I gave a description on how to download Jupyter Notebook using Anaconda. So you can do that so that you can, as you watch the videos, you can practice alongside, and then you can tweak the codes, change things, and see how things come. And then by doing that, you can actually get familiarized with, you can familiarize yourself with how these things go. So today we're talking about introduction to SciPy. Of course, you want to be sure not to miss anything afterwards. So if you have not subscribed to this channel, you want to do that. You also want to hit the notification bell so you can get alerted each time a new video is released. Also, feel free to comment on whatever you like me to talk about, maybe in Python, or maybe in mathematics. I have quite a number of playlists on mathematics, on matrices, on basic calculus, on complex numbers, on trigonometry, and so on and so forth. So you can check these things out so you can actually understand. In fact, closely related to what we're doing here is the concept of matrices. And I have a whole playlist on matrices, I think about 26 videos or so on matrices. So if you want to understand the theory behind some of the computing thing we'll be doing here, which involves matrices, you can actually check that out. Okay, finally, so of course, don't forget to comment, to like, and to share. Introduction to SciPy. Like I said already, SciPy is scientific Python, and it's an open source Python library used for scientific and technical computing. Interestingly, it is built on NumPy. In our last series of videos, we talked about NumPy a lot. That's numerical Python, which is particularly good with arrays and matrices. So SciPy provides a large number of high-level functions that operate on NumPy arrays and are useful for various scientific and engineering applications. And of course, SciPy is part of the larger ecosystem of Python scientific libraries and is widely used in academia and industry. So a whole lot of simulations that you may want to do may involve the use of SciPy. And of course, its comprehensive suite of tools and functions makes it a critical component in the toolkit of scientists, engineers, and data analysts working with Python. All right, so what are the key features and modules of SciPy? Of course, you should understand the SciPy contains a variety of sub-packages for different kinds of scientific computations. First of all, we talk about SciPy.linalg, that's linear algebra. So the SciPy.linalg module offers linear algebra routines and matrix decompositions, which you're going to see in the next video. An example is solving a linear system. You have a system of equations and you want to solve that using Python. So what you will use is linalg in SciPy. And of course, there's SciPy stats. SciPy stats, of course, as you can see already, the SciPy.stats module contains a wide range of statistical functions and probability distributions. All right. And of course, an example of that would be calculating descriptive statistics like mean, median, mode, and all of that. And of course, there's SciPy interpolate. Interpolation means maybe you have a data set and there are some missing data points in between. So to interpolate is to use some techniques to fix values, to fix those missing values. And of course, this happens a lot when you're doing data analysis. So they are missing data and you don't want to just delete them or leave them blank. So you can, interpolation is one thing you can do to take care of those data that are missing. The SciPy.interpolate module is used for interpolation, which is the process of estimating unknown values that fall between known values. You know, there's interpolation, that is values that missing values or unknown values that are between known values. But then there's extrapolate, that is unknown values that fall outside known values. That's extrapolate. So, but here we're talking about interpolate. For instance, we want to interpolate a one-dimensional function. Then, of course, we have SciPy.optimize. The SciPy.optimize module includes algorithms for function optimization, root finding, and curve fitting. For instance, you have a quadratic equation or any kind of polynomial you want to solve. So SciPy.optimize is what you use for that. Or you want to do some optimization stuff. So SciPy.optimize is the go-to for you. And of course, there's SciPy Integrate. SciPy Integrate. SciPy Integrate module provides functions for integrating functions and solving ordinary differential equations. And an example is integrating a function. You know, I have a playlist on basic calculus, which you can refer to. So SciPy Integrate. All right. So, and you should know already that most phenomena in nature are actually represented using differential equations, either ordinary or partial differential equations. We have SciPy Spatial. SciPy Spatial module contains spatial data structures and algorithms, such as KD trees and functions for distance computation. So maybe you want to talk about some geography, you want to find the distance between 2 points and things like that. SciPy spatial is your go-to. So computing the distance between 2 points, like I said already, like of course using longitude and latitude, you can actually find the distance between two locations, right? There is SciPy.fft. So SciPy.fft module provides tools for computing fast Fourier transforms, you know, like for signal processing and things like that. So computing the FFT of a signal, for instance, you can use SciPy.fft. Okay. Then you have SciPy.signal. Of course, now that you have the whole idea of signal coming up here, right? It means that this SciPy can actually be useful if you are into engineering, like telecommunications, you know, geographical information systems and things like that. Then you have SciPy.signal. The SciPy.signal module is used for signal processing, including filtering, convolution, and more. So, for instance, you want to apply a Butterworth filter. Butterworth filter. So SciPy.signal works well for that. So that's our introduction to SciPy. And in the subsequent videos, I'll take each of those packages and actually go deeper into them so you can see their capabilities. So of course, you don't want to miss any of that. So if you have not subscribed, you want to do that right now. Subscribe. And of course, hit the notification bell. So anytime a new video is released, you can get alerted and of course be one of the first people to interact with that. And interestingly, don't forget the notes are available, so just check the description box. You'll find a link to the notes and you just click and download. And even if you don't want to download, you can open them in in Google Drive, such that you know you can get them open in Google Colab, which operates basically like Jupyter Notebook. So see you in the next video. Thanks for stopping by. Okay.